the details of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree, which are very uh, mm, general kind of ratios. So for that purpose, let us again make 90 degree angle. So for that purpose, let us again make a right angle triangle. First of all, we want to have a look on these angles. Let us take this 45 degree first. We know that when this is and this is 45 degree, then this is 45 degree, then this has to be 45 degree because this is already 90 degree. So 90 plus 45 plus 45 will be equal to 180 degree. But there is one very important fact here. In the geometry, you might have read that when the two angles are same, then the sum of those two, the two sides will also be the same. So BC is in front of this angle and AB is in front of this angle, and both of them are 45 degree. So AB is equal to BC if we are dealing with 45 degree angle. Okay, then what will be, let us start with tan theta. What will be the tan theta? So here, if we base our angle, if we base this angle as our basic angle 45 degree, then this will be B, isn't it? This will be P and this will be H. So but we know that P is equal to B. Why? Because these two angles are also the same. So when angles are the same, then the sides also need to be the same. So what will be the value of tan theta? We know P is equal to B, so that will be basically equal to 1. So tan 45 degree will be equal to 1. Okay, what will be tan 0 degree? So just have a look on this triangle again. What if this 45 degree becomes 0? When this will become 0, point A and B will converge and side AB will also become 0. Or P will become 0. B will be the same. B will be the same. This will become 0 and AB, this point A will converge to B and AB will become 0. So P will be 0. It means P will be 0. So tan 0 degree will be again P by B, isn't it? Means 0 divided by B means 0. So another thing which we established now is tan 0 degree will be 0, isn't it? So tan 45 degree we found out, tan 0 degree we found out. Okay, let us imagine one more thing. Let us try to find tan 90 degree. Imagine this angle 45 degree, which is our base angle, becomes not 0 degree but 90 degree. What will happen then? Then AB has to be very big, so big, so large that this angle will become 90 degree, and then this angle has to be 0 degree then, and the triangle will just look like something like this. And A has to go till infinity so that this angle becomes 0 degree. This also 90 degree and this also 90 degree. This is a kind of imaginary situation. It's imaginary. It cannot happen actually. This is what we will deal with in calculus whenever something becomes when we need to deal with infinity, etc. Then we just take the help of calculus. Here we are not talking about any real situation, but one thing we are quite certain about: this tan 90 degree, which will again be ratio of P and B. Here we know that P will be a kind of infinity. B will be the same. There won't be any change in B. But this will become infinity. So tan 90 degree will be infinity. So we have defined a few of the ratios, tangent ratios: tan 45 degree, tan 0 degree, tan 90 degree, etc. But we have not defined tan 30 degree and tan 60 degree. We will do everything. We will do everything one by one. But let me show you one very important fact, or a kind of a table. Let me make a table including all those angles which we talked about. So, and this is very important table. This is also kind of mnemonic technique: sine, cos theta, tan theta. Okay, you can also make these tables. We will just write just write 0. Okay, so here we are dealing with 0 degree, 30 degree, and then 45 degree, 60 degree, 90 degree. Okay, this is not required, so that's okay. Just write 0, 1, 2, 3, 4. And here for cos theta, just write it in just reverse. Okay, so here for sine theta we have written 0, 1, 2, 3, 4. For cos theta we have written 0, 1, 2, 3, 4, but in opposite direction. And then divide everything by 4. Everything. This is also very easy way to remember the trigonometrical ratio. And then just take square root of everything. Here, here, here. Okay. Now we have got all the values of sine theta and cos theta. Sine 0 degree, sine 30 degree, sine 45 degree, cos 60 degree, cos 90 degree, everything. So actually, let me just write down what is the exact value. So here you know that sine 0 is 0 degree. And here you can see that this is 1 by 2 basically. And here this is 1 by root 2. When you will do this calculation, you will find it is 1 by root 2. Here this is root 3 by 2. And here it's 1 actually. So sine 90 degree is equal to 1. And same in opposite direction, because we just followed the opposite direction. Just by doing some calculation, you can very easily find out the value of all these angles. Okay, so this is looking like a kind of magic. Why it is happening, why it is why such kind of pattern is followed, that we will look into later. but let us do it for the tan theta also. Tan theta is nothing but sine theta divided by cos theta, isn't it? So 0 divided by 1, it will be 0. Here 1 by 2 divided by root 3 by 2. So 1 by 2 divided by root 3 by 2, which will be equal to 1 divided by root 3. Here 45 degree, it is nothing but 1 by root 2 divided by 1 by root 2. That will be 1, isn't it? And that we also found out earlier. Here tan 60 degree will be nothing but sine theta divided by cos theta, which is root 3 by 2 divided by 1 by 2, which is root 3. And then what is this one? Sine theta divided by cos theta. 1 divided by 0. Again, it is undefined kind of thing. Not undefined, but this is infinity. So tan 90 degree is infinity. So we can neatly write down all those things. Again here, I will just make a table so that it will also act as a note for you. Zero degree, 30 degree, 45 degree, 60 degree, and 90 degree. 0, this is also 0, this is 1 by 2, this is also 1 by 2, this is 1 by root 2, this is also 1 by root 2, this is root 3 by 2, this is also root 3 by 2, this is 1, this is 1. And then tan 0 degree is 0, tan 30 degree is 1 divided by root 3, tan 45 degree is 1, tan 60 degree is root 3, and tan 90 degree is infinity. Okay, looks like a kind of very interesting pattern which it follows for these important angles. Why is it that? We have already learned, for example, if we want to see, okay, why is this 1 by root 2? It's just very simple. Because for the angle of 45 degree, let us make a small triangle, right angle triangle, where we are telling, okay, this is 45, this is also 45 degree, 45 degree. Then this will be, this side will be a, this side will also be a, and we found that this h is equal to root 2a. You can just refer our previous pages in this video. If we just make this angle as a base theta, then sine theta will be equal to p by h, and that is p is a and h is root 2 times a. So it means 1 by root 2, isn't it? Then same thing, cos theta, b by h, b by h, b by h is b. How much is b? B is this a, and then h is the same, this one. So for a 45 degree angle, sine theta as well as cos theta have the same value, and tan theta, tan 45 degree is equal to 1, we have already seen. What about the other way? What about some other way of finding the trigonometrical ratios? For example, if we have, just now we have not tried to establish a way to find cos 30, for example. sine 60, etc. So 30 degree and 60 degree we have not yet looked into. We have looked into 0 degree for various angles, 45 degrees for various angles, and also some 90 degrees. Let us concentrate of or try to find out this 60 degree angle. So for that purpose, um, we have we can take advantage of basically equilateral triangle. You know what equilateral triangle is? It is triangle whose all angles are same. All angles are same. So if this is A, this is B, this is C, three vertices of the triangle, then all angles are 60 degree or the same. If all angles of any triangle is the same, then it has to be 60 degree, isn't it? And then all the sides will also be equal, because we know that the sides and angles follow the same ratio. That is the basics. Again, let us do some constructions here. Put perpendicular line from A. Call it D, for example. When we are putting perpendicular line, we know that this is 90 degree, isn't it? And then by geometry, we know that we have actually divided this angle into two angles which are equal, because this equilateral triangle has symmetry. And for this symmetry, if we just put a perpendicular line, it will also bisect the angle in equal part, isn't it? So let us go forward. First of all, we have already declared that this is equilateral triangle, isn't it? What does that mean? It means side AB, BC, and AC all are equal. Let us assume it's a meter or centimeter or whatsoever. Let us assume AB, side AB is a meter, BC is also a, AC will also be a. Why? Because this is equilateral triangle. And then we have just put a perpendicular on it, this perpendicular on it. So do you have any guess about what this side DC will be? This perpendicular will divide not only the angle but this side also into two equal part. How? Because of the law of symmetry, you can say. I will not go into the geometrical details of that. It could be proven very easily. But in that case, what we are telling that BD is equal to DC, and that will be equal to basically A by 2 then. So DC will be equal to A by 2, BD will also be equal to A by 2. Okay. So now you concentrate on a triangle ADC, this triangle. Okay. So in triangle ADC, DC is Measurement of side DC is A by 2. Measurement of side AC is actually A, and which is hypotenuse, isn't it? This is hypotenuse of that triangle. When we say that this is our base angle or theta. So DC is A by 2 and AC is A. What will be the measure of angle AD? Again, by Pythagoras theorem, it will be nothing but hypotenuse square minus base square square root. So AC is A square and then DC is A by 2 whole square. It means 3A square divided by 4, which is 3A by 2. So in that case, let us try to define sine 60 degree. So sine 60 degree is nothing but AD divided by AC, isn't it? AD divided by AC. So what is AD? AD is root 3 A by 2. AC, what is AC? AC is A. So root 3 by 2. So we have again proven that sine 60 degree is root 3 by 2.